Well, welcome to Kramer Talk. Robert Kramer here. I'm here with a special guest. Before I go into Mr. Mason on the phone with me today, just a little bit about Kramer Talk. Kramer Talk brings together analysts, vendors, customers, industry leaders, really about conversations about technology that we're talking about today and trends within ERP, supply chain, data, AI, and the future of enterprise technology. So today I'm joined by Colin Masson, who brings a great perspective really about manufacturing, industrial technology, AI, and all of it, really how it comes together. Colin spent a lot of years really looking at IT and OT and data and operations. So we're here to talk about his perspective on that and what that means when agents start taking action and where ERP fits into all this, if it does, because I kind of think it's more of like a larger platform ecosystem. Colin, how are you doing today?
I'm doing great, Robert. Looking forward to the conversation. We obviously cross paths quite often out there in that ecosystem. So looking forward to it.
It's fun when you meet different of our peers at these events, because we all go to these vendor events and sometimes customer events, or sometimes customers at the vendor events. We get to cross path with really smart people and have conversations. And when I sit down, and you do too, next to other analysts, we really get to understand what their makings of them are and how they got into the industry and why they're in the industry. I know we have a bunch of different questions, but before we talk about those, how'd you get into the industry and how do you understand the math of manufacturing?
Well, I'm old school. I have a degree in chemical engineering, and that's kind of where I started in manufacturing. And then I went straight into process investigations in factories. And so I've worked in factories early on in my career. But early on in my career, I got pulled into projects where, as the youngster, if you like, I was encouraged to explore emerging technologies for what we called computer integrated manufacturing, if you can remember that term, right? So I quickly transitioned and started crossing that kind of IT, OT boundary, because I had to justify technology for the factory and who held the purse strings, right? So that kind of took me into the beyond being an OT person or operational technology focused engineer to crossing into kind of broader ERP, supply chain. And of course, now we're into the wave of what I like to call industrial AI. But that's kind of my background. So I'm one of those people that, yes, worked in factories for decades, but then moved over probably more to the IT enterprise level, justifying systems that hopefully benefited the whole enterprise, but the factory as well. So that's kind of my story in a nutshell. It's probably a bit more complicated on LinkedIn, but that's the core.
Well, what's interesting about it is that you understand the foundation of manufacturing and the tools that were used, I guess, in like industry 3.0 and 4.0 and how we're going along this path. It's more, the goal is, how do we make these facilities more efficient? How do we use technology to be a better manufacturer? And how do we have data that comes back to the whatever technology we're using to use and to be more of a system of action, to not just record the information, but to do more business with the same amount of employees and understand the variables in front of you so you can have the logistics and have the correct suppliers, et cetera. So now when we look at AI in manufacturing, which is, I don't know if it's a wrench or just an amazing tool or both, but what feels real to you and what feels like it's a lot of noise? Because AI, where it fits in some cases, is completely amazing. And sometimes it could, I guess it's one of those tools that shows you the weaknesses in company, whether you want to know it or not. But I guess that's what you want too. So what's your thought?
Well, I probably should start by framing what I like to call industrial AI before answering that question, because machine learning, neural nets, computer vision, rule-based symbolic AI have been deployed for decades in manufacturing. So I find it a little bit galling that somehow there's a perception that manufacturing is a laggard, right? In AI, usually by those that think LLMs are the only form of AI. So when I talk about industrial AI, and I make it a habit to kind of frame industrial AI to make sure we're talking about all the AI tools in the toolbox, right? Everything from clearly LLMs, but I also like to consider the next wave of multimodal frontier models. You've got neural symbolic AI, which kind of takes the blend of LLMs and that rule-based logic that we almost started the AI wave with decades ago. And they're coming together. Physics-informed neural networks are a big thing now, large behavior models for robotics. So I like to frame, firstly, when we talk about AI, let's talk about all the tools in the toolbox. And I think that's where we can really have a deeper conversation. Now, what we have seen, to answer your noise versus what's real question, I think the noise, frankly, and I'm busy with a report on industrial copilots, right? So here's a classic example where there's a lot of LLM as chat widgets. It's somewhere in the bottom right-hand corner, or I guess it can be somewhere else, but that's the most often you kind of see it stuck down there in the corner. And it's just a lightweight wrapper, general purpose, and doesn't really include a native understanding of the process chemistry, the fluid dynamics, or just think about it as all the physical and chemistry constraints where you can't be 90% confident and you can't hallucinate, right? If you're going to make decisions on that. So there's a lot of co-pilot washing. And part of what I'm doing in my latest round of research is kind of looking at all of them. And there has been a co-pilot evolution, right? A lot of them starting to use the techniques I talked about a little bit earlier to bring in some of that rule-based logic or handle the physical constraints. So that's one of the areas where there has been a lot of noise, a lot of companies trying to build their own co-pilots and realizing LLMs just don't cut it, right? There's a lot of other plumbing you have to do. What I think is real is back to the physics, right? We're seeing things like physics-informed neural networks now being applied to a wide range of industrial AI use cases where you have to have that understanding of the physics. I think there's platforms, and I don't know if I'm allowed to talk about specific vendors on your podcast.
Sure, go for it.
Right. So there's like somebody like an Aperio Systems that really is very focused on real-time data quality. And so they're looking at that petabytes of real-time data that you can have in a factory and really making sure there isn't drift or bad readings creeping into it. So you've kind of got that data quality type solution that's really starting to become a must-have, because once that boundary data moves away from the edge and people start to use it, it's kind of like, well, if it's poor data, garbage in, garbage out. So I think we're seeing a lot more discipline around that now. And then I kind of alluded to when you're in the real world, and we might get into this later in the conversation, but there's this discussion of autonomous execution. When do you let AI actually close the loop, right? And we are starting to see some solutions, and it varies, right? At the ERP level, you can close the loop relatively confidently with a wide range of use cases, or in supply chain where the physical consequences are not. There might be monetary consequences, right? But you're not going to kill people or shut the plant down with a poor set point decision, right? And so we're seeing real implementations, and I'll call out somebody like Immubit, right? Because I was at their conference in Houston about a month ago, and we were looking at their deep learning process control. So it's very much deterministic, highly predictable. And that is something where it really does understand the plant and you can make decisions on it, and you could write back the set point. So, but I mean, those are still relatively niche in factories because of the consequences, right? So it's still mostly recommendations that are coming in, but the recommendations themselves are getting better as people start applying the right AI tool for the job, right? So they return back to more deterministic techniques rather than relying on frontier models that, one, are very expensive to use. I think we've seen that with the token apocalypse, if you want to call it, where people are getting bills that they didn't expect. And that's almost forcing them to go back to looking at, hey, well, maybe we should pick the right tool, right, that gets us the accuracy at a fraction of the cost and apply that for the set of problems where it will be much more realistic and much more cost effective. Back to your earlier point, right?
We're here in this situation, and I think it's a good one because these companies ran their systems as a more of a turnkey solution where it was just a system of record. They closed the books, they moved on to the next month. They had all the data there. The data was either good or bad. They had the customer in there 5 or 10 times or 20 times. Everybody put in different information in different areas per what was best for that person. It wasn't regulated heavily. Now we're here, and actually even a few years before this, additional softwares were bought to fill in gaps and fill in processes that they thought they needed. So now what we're going through, and we're seeing these things that you said there's messes here, the data's not good here. It's kind of a good thing because this shows me as a business owner, like, wow, I kind of let this go in a way that is a little bit the wrong direction. Now I can rein it in. I can fix my processes. I can get the technology that fits, not to fill those processes, but where my processes don't exist. And now I can get my data where it's in better shape, because the real technology hasn't still hit yet, in my opinion. We're on the verge of it, but we haven't really got there. So it's a great time to start your modernization effort. So with that, we spent years, like I said, talking about these different things, but also about IT and OT as two separate worlds. You were kind of talking a little bit about it, but is AI, and I think it is with what I just said, but is it forcing those worlds to come together?
I agree 100%, Robert. I don't think I've seen as much progress in IT, OT, and sometimes I add ET to the equation, right? The engineering group, right? But not the movie. But I've seen this convergence of IT, OT progress more probably in the last 3 or 4 years since this new wave of Gen AI, right, that has kind of influenced both audiences. So I think everyone sees the opportunity and there's shared and common interests, but IT needs the data, and the data, right, that they need, a lot of that is trapped on the OT side, right? And if you add the data science audience, you've got another team that wants that data because that's where they can really drive a lot of the real business outcomes from understanding the factory or the supply chain more deeply. But if you can't bridge these gaps between IT and OT, they're kind of hamstrung. To your point, if you don't solve this long overdue problem, and I just wrote a piece on 25 years ago, I was talking about enterprise manufacturing intelligence in my previous stint as an analyst. And of course, it was the same. At that time, I had this framework where it was about connecting devices, right? It was about aggregating that data where it makes sense. It was about contextualizing that data. And then you would analyze that data, and then you might propagate it to other systems outside of the factory. And I wrote that 25 years ago. Right? And now all of a sudden we've got
full circle,
but now there's real action, right? So now we have people going back to solving the basics, right? How do I get data quality? How do I add context to that data so it's usable by now teams of data scientists, right? That are trying to build not always AI solutions. Everybody can benefit from the contextualized data, but AI is the real driver, right? It's really forced IT and OT to talk together. One of the barriers to that has been, and this is where we're also seeing an evolution in how people think about the silos, right, between supply chain, factory, ERP. So really a lot of that people turn to things like the Purdue model pyramid and ISA 95, which is a very rigid physical network execution boundary mechanism, right? But it fundamentally stifles the agility for what we're trying to build now with agents and software-defined automation or software-defined manufacturing. So it changes even the physical layer. So now, who would have thought we're talking about virtual PLCs and
Right. It's fantastic.
It's fantastic, but again, it's hamstrung by decades-old thinking in terms of hierarchical segmentation of the network.
But we went through many years where the data wasn't recognized as understanding when you put something in what the downstream is until probably AI is really hit. Because I was a former CMO at a company and we had the major ERP vendor and a major CRM. And
Right.
the people that work for me were like, why is blah, blah, blah so bad? I'm like, well, why do you think it's bad? Like where the data is coming from? I'm like, no, nor did they care, nor did we have governance about what fields got put in by certain people. So the downstream is, first of all that data, all these master files, they're extensive and complex for a reason, because first of all the customers want it, but then you want that because of the downstream and what it creates for you. But no one has it perfect because it wasn't governed correctly until it's talked about now. So, and then you got the people, and that's what this next question is a little bit about, because the people are super important and the people have the knowledge that is required for all this to come together. And we have to understand that mindset of these people, because you can't have them change without them wanting to. So when we talk a lot about manufacturers and their old systems, and I was getting to a point about people, and we were talking a little bit about industry 3.0 and 4.0, and we're probably at then going to 5.0 and 6.0, and 5.0 is a collaboration of humans and robots. And when you talk about the messy data and the critical knowledge sitting with a few experienced people, I think it's important to know what those people have in their mindset, because they bring that experience. But how do you build AI on top of these older systems and the data and really the people? Because the people, I think, bring everything to really what needs to happen, because it's specific to a company. They know what processes work, and you're not trying to replace the processes that work. You're trying to fill the gap. So how do you build AI on top of all this without creating a bigger issue?
And there's multiple topics to flesh out there, I think, Robert. But yes, coming back to the IT-OT convergence, we've seen AI drive a lot of collaboration on standards and models. So I think that's part of what's enabling us to overcome some of the friction of legacy systems, and agreeing with you that there's this legacy that we have in manufacturing with heterogeneous and complex systems. I've talked with companies that have hundreds, if not thousands, of different systems in their factory. But in some industries, they put in distributed control systems that are going to be there for 30, 40 years. Yep. So on the one hand, you've kind of got this legacy of complex and sometimes old systems that weren't designed to be connected or provide the data you need. And on the other hand, you've got a workforce that has been constrained somewhat by the fact that they don't have that data. I think I talked to you. My first job was process investigations. I would spend 80% of my time trying to get data about what happened in the factory. And so I'd love to be in the modern factory where I'm getting all of this data contextualized, and then that's my starting point, and then I can start to look at solutions. So on the other hand, there's an aging workforce issue that we could spend hours talking about. But so you've got a problem with people that are used to working on old systems or keeping lots of notebooks and knowledge that isn't captured digitally because it's in their minds. So you've got that aging workforce problem, you've got the legacy systems
Mhm.
problem. And again, I would say we're starting to see light at the end of the tunnel in terms of AI has driven IT and OT to collaborate to the extent that we're now talking about standards like model context protocol and agent to agent, right? Which now let you not force an organization to rip and replace all of that mission critical hardware that they couldn't afford to replace anyway.
Yep.
But it can stay in place, and we can now start to put wrappers around that to get at the data, contextualize it, and make it available to IT, data science, or just supply chain needs that data. How long have we talked about just manufacturing and supply chain working on against each other, one trying to lean out the factory and the supply chain trying to make it more agile because they really don't know what's going on in their respective
Absolutely.
domains. So I think that's really where I'm starting to see things like SESME and i3X, which is kind of suddenly addressing and almost creating that modern API that can be used by agents to get contextualized data from manufacturing systems. So there's huge support for that, even though we've had this problem for decades. Now, again, in the last couple of years, driven by AI, we've made more progress than we did in the last 2 decades, right?
Fun. But
yeah.
so I'm going to combine these next couple questions. But
Yeah.
so where does ERP fit as all this evolves? And one of the things that I actually just wrote an article about this in Forbes of when do you actually start letting AI do some of the work that you think needs to happen that isn't happening yet? Like, what's the juncture where you tell someone it's time to let go of this and let AI do it? What's that point look like? Is it trust? Is it good data? Is it the efficiency that's going to bring? It's just time? You do it in baby steps. You do it in full swoops. What's your thoughts on all that?
Okay, so you're kind of asking me about the evolving role of ERP
Yep.
and to some degree the autonomy of
AI within
AI within that. All right, so and I think you and I both talk a lot with the ERP vendors. I tend to talk more from I guess, the factory up, and you're probably coming at it more from the broader value chain perspective. But I think we've probably seen the same thing, and the one that it's tough not to talk about is kind of SAP and the evolution of their strategy, because they need to capitalize on AI for their customers. And part of what we've seen is, I guess, SAP's taking an approach because they have so much technical debt with their customers and highly customized systems that they kind of switched over, right, to you have to have a clean core. Just as you talked about work you're doing with SAP, I talked with Jabil, right, on a webinar a few weeks ago, and we talked about how were they driving their, I would call it, pace-setting adoption of AI as an industrial organization. And one of the things they highlighted was clean core.
Yep.
And data governance, and that it was kind of like, well, we've kind of had to narrow down our ERP implementation, run global operations on a clean core, and pairing it with a kind of governed data platform approach to make sure that we are getting the benefit both of the clean core, but also zero copy, virtualization, things that Databricks talks about, obviously. And so they are really talking about the benefits that they can now take advantage of what SAP is actually delivering in terms of agents and understanding their model. So on the one hand, that ties in with what we've been recommending to clients, particularly laggards, right, who don't have the budgets or IT teams, or actually more critically, the data science teams, to go and build their own models. We've been telling them, hey, you've just got to take advantage of whether it's your CRM platform, your field service platform, your ERP, the enterprise solutions are going to infuse a lot of the AI benefits. But to get there, they either have to have a modern architecture, which is where I would see, let's say, IFS and Infor maybe having slightly more modern platforms suited to agent enablement, right? They've got a nice solid core that they re-architected a few years ago, right?
I
So
think a lot of,
yeah.
not to interrupt you, but I think a lot of the vendors are going towards a larger platform, meaning not
right
size, but structured with AI, data, security, governance. The customers want more of a simple approach, more of a turnkey solution with an ecosystem that supports that platform. So they're not necessarily looking to buy an ERP system, they're looking to buy a platform now. And
Right. And to that extent, more about this, Robert, you talk about this all the time, but really, I don't see ERP going away, but it is evolving, right? It has to. And to your point, it's becoming more of one of the centers of gravity, a big center of gravity for your AI aspirations, because it still is the system of record for a lot of the enterprise functions. ERP vendors have got different technical debt and different means of getting there, but ERP is not going away. But I think this is starting to highlight a different problem. So let's just say ERP, whatever you want to call that next evolution, Robert. And I don't know if you have a term for that, but it to me, it is a major center of gravity for driving AI business value.
yes.
Doesn't necessarily extend all the way to the factory floor, and some will point out limitations in supply chain, right? So you do have, let's say, the supply chain decision intelligence is kind of an emerging area where I think in some ways they're very advanced in terms of their architecture and how they can take advantage of agents, and their supply chain knowledge graphs can be a major contributor. So that could be another center of gravity. But the factory remains another center of gravity.
Yes.
And I think the questions start to arise about, well, what if an agent, not necessarily a person anymore, right? But what if one agent, a procurement agent, wants to change the specs because it can get a better deal on a raw material without understanding the impacts on the factory? Meanwhile, the factory is being told by the supply chain to ramp up production of a different product. So you can see how these agents start to contradict each other. And so as we start talking about this future of multi-agent orchestration, right?
Yeah.
That is starting to become, I think, more of the concern, because each of these centers of gravity, the ERP, the supply chain, the factory, each have champions building agents. But yes, there's this thing called agent to agent, but it's not all that mature yet. And it's not the ability to talk, it's the ability to coordinate, right? You need a level of multi-agent coordination, right?
Yep. And I kind of call it like the execution layer it's becoming, or a decision architecture. We're going to more of, like I said, that platform, but where these agents can cross over from application to application. But as they start doing this and they're running more, you're running more agents, you're running more models, you're running more AI workloads. And the cost is kind of a little bit cloudy as far as how it's going to be like built, bought, managed.
Right.
And in a sense, is it a nice to have that doesn't cost anything? Is it billed as a person, as an actual user? Was it consumption based? I think it's not figured out yet, but it's a good discussion, and I know we're kind of closing on time, but what do you think about that?
Well, why don't we postpone that one, because I'm doing a lot of work on really, I guess, the economics of people versus AI.
Yeah.
And I'm kind of, on the one hand, I'm optimistic that people should be reskilled, are going to very much still be part of that equation.
Yep.
I'm not as naive to say, oh, it's just going to augment people. I think we already have a gap.
No, it's not.
Right. And so there is going to be, and I talk frequently to organizations where they're doing their own calculations, right, on how much can I get AI to do to fill my existing gap in skills in factories, versus arming a new generation of frontline worker. I use the term synapse worker, but somebody who knows enough to be the voice of reason, right? When it comes to working with agents, spotting problems. So they've got to be comfortable enough with AI and understand the domain problem that they can be the safety valve and that coordinator until we have better technology and we have better trust in the accuracy of the AI agents, right? So I think that's a whole conversation on its own that we should set aside.
We'll do a part 2 for sure then.
Right, we'll do a part 2, but I don't think we address the autonomy, which comes back to a part of that, right, which is the trust. So let's say we've got these centers of gravity. Each one of those centers of gravity, whether they're ERP agents, supply agents, or factory agents, I think they're all trying to come up with an answer on how much do we have human in loop. So it's really more of an advisory augmentation, which is kind of what everybody says if they don't want to talk about people versus paying for this technology, right? You have human on loop, right, where you're almost there, you're building trust in the agent, but you still have a person who has to sign it off for liability reasons or just confidence or change management, getting them confident with the AI. You kind of have human above the loop, which is really where you start talking about a true loop where you've got multiple agents all making recommendations, and you need somebody that's really going to look at, hey, I need to revoke that agent because it's giving me garbage, and you've kind of got a human above the loop but still engaged and monitoring and intervening. And then you've got a full digital autonomy, I think, which is relatively rare in the factory for reasons we talked about before, where it's almost a non-starter, right? Because unless that it is 100% accurate, guess what? Even today, they override control systems using much more, right? And so it's like, okay, are you really going to have that? Different story when you talk in ERP or when I talk to supply chain vendors and they're autonomously retuning inventory, right? They'll do that. They'll record it, and you can, but you've got time, right? And you've got time to kind of say maybe the AI was too enthusiastic about reducing that level. Maybe I'll just adjust it and move it back up, right?
Sure.
But you don't have that in a factory where, hey, I might need millisecond response, or imagine robots, right, walking around, and that computer vision system has to detect a person and adjust in real time, right? Very different context.
It's all fascinating, and I'm excited for this next couple of years. We'll see what happens, but I want to thank you for being on the show. We're going to do a part 2, and I know that we've gone a little long on this. I want you to hang on while we go through the ending here, but thank you, Colin, Robert, Kramer with KramerTALK. We'll see everybody next time.